what's up, guys? I'm still behind on a day or two of this year's Advent of Code, but we'll get there. Let's take a look at today, because so far the even numbers have been easier. Day 6 is called Wait For It, and it says we've got this boat race with these little toy boats that hold a single button. When you press the button, it charges the speed. So the race is limited to time, and we're trying to go as far as we can. Not charging it at all means you go nowhere. Charging it the whole time also means you go nowhere. But there's some optimal mix in the middle where you charge a little bit and let it go a little bit to reach our best distance. And we're not actually looking for the best, we're looking for anything that beats a certain record. So in this first race we have 7 seconds and we're trying to beat 9. So anything that beats 9 can qualify. You could imagine a parabola and then a line through it, and we're taking the part of the parabola that's above that line. In this case, they list out every possibility because there aren't that many, but with a bigger race, we'll just have to imagine. So if you don't charge it at all, we never go anywhere. If you charge it the whole time, we never go anywhere. If you do 1, then it goes for 1 unit every 6 units of time, so we go 6. If we charge it for 2, it ends up going farther, even though it starts later, because the speed catches up. And then we have some even better than that, and then the parabola starts to fall in a mirror image. So in the back of our minds we think maybe just calculate the first half and double it from there if we need to. This is pretty simple, and then they ask us to multiply the ones that qualify, the good ones. So just like in the last video, I'm going to have part 1 ready, and then I'm going to do part 2 while explaining it. Luckily, the input is nice and small. We don't have a zillion lines, and parsing it is pretty simple. We say, okay, split on the colon because we don't need the name, and then split on the spaces because we need separate numbers, and then we turn them to integers. Same thing here, although I changed the name. I'm not using the name distance, I'm using the name records because that fits more with the theme, okay? And I want to use the word distance for myself with how far I'm going on each possibility. So I zip these because I don't want to go down the line separately. I want to say this bundle of 7 and 9, this bundle of 15 and 40, and so on. Then I loop through that, and I say, okay, imagine charging. We don't have to do 0, and we don't have to do the full thing, because they would be failures anyway. So from 1 to t, imagine charging, which makes you go a little less time, but it makes you go a little more per unit of time. If that qualifies, then we add 1 to our total. So this is a Boolean, true or false, 1 or 0. And then I'm appending that, and then I'm math.prod to multiply. You could also reduce, or you could also do whatever. And then if we run that on the test, it should be the answer they were looking for, which was 288. Now let's run that on the big data, which is not too bad. We don't have to worry about any optimizations yet. I get 505,494, and that was in fact the right answer. Excuse me. Next, it says part 2, they weren't separate columns. This is one whole thing, and this is one whole thing. So this is a big number and a big number. So I'm going to do a new parse function, and I'll just call it parse2. And we'll say, okay, I don't need any of this stuff because I'm not treating them separately yet. I'm going to join all of that and then int. Okay. I think that's right. And I'm gonna join all of that and then int. I'm also going to change the name to a singular, and we'll just return a tuple instead of a zip. Let's print parse2 of the data. So it should give us, or no, of the test. It should give us, 71530 as a single number, and then 940200 as a single number. Hey, there we go. That's great. Now, part2 function is going to be, in some ways, simpler because we don't have the zip extra layer. We're just looking through a single number. But of course, now the for loop is a zillion times longer because it's going through thousands of things. And Python's for loops are not known for their speed. So is it going to take 24 hours? Can we do it? Should we optimize? That's the question. We don't need this layer. Well, maybe the total. We'll see. And we probably don't need this layer. So let's unindent these guys. And let's say, okay, well, we do need a parse, even though it's not a zippy thing. So I'll just say tr equals parse2 of lines, and then for charge in whatever, we do this, and then okay. But now we're gonna use it, right? I'm gonna say like, or can we just return total? It seems so suspicious, right? Let's do it on the test. And I'm not printing it right. Part2 function, that's the danger of copy paste, is that you forget to change things. 71503, is that their test? 71503. So here's the question. Is it going to work on the big data? Because the big data is still only 2 lines, but they're bigger numbers, right? So let's hit run and see. It might take a minute. You see, this is what happens. It's running, and hey, it worked. It only took a couple seconds. So this is like the bad way of doing it. I don't even need these variables. It's completely brute force, just looking through all the stuff. Like I said, we should be able to optimize. We could take the first half of the curve, and then we know that it's going down in a mirror on the second half. We could find out the pattern of the curve and then just do some of it and calculate the rest according to some equation rather than actually looking at everything. And maybe there's a way I haven't thought of to just algebraically make a formula. However, we got it. The computer took a few seconds instead of a few days, so we lucked out as long as this answer works. And in fact, it does. So I kind of feel bad about this one. It's like when you go up to a video game boss and you beat it on the first try with a silly move. You think, oh, come on. I deserve another shot. He deserves another shot. Let's have a fair fight again. So I might go back and do this one with a little more thought, or just imagine like what if it was 10 more digits to spice it up. But this was interesting, and it does seem to follow a pattern that the days 2, 4, and 6 have been easy, whereas 1, and especially 3 and 5, not so much.